A quadratic equation is any equation of the following form: ax squared plus bx plus c is equal to 0. Let's write some examples of quadratic equations. 2x squared minus 7x plus 3 is equal to 0. The next equation is x squared plus 6x plus 9 is equal to 0. And the last example is 3x squared minus 2x plus 2 is equal to 0. How can we solve quadratic equations? First of all, we find the general form of the solution of the quadratic equation, and then we will use it to solve our equations. We have to use a well-known formula. The square of the sum of two terms is equal to the square of the first term plus twice the product of the first term to the second, plus the square of the second term. This is the well-known formula for squaring a sum. If you look at our expressions, they look alike. Can we transform our general equation in such a way as to make the perfect square? To transform our equation in the quadratic trinomial, initially we factor out the coefficient a. Let's rewrite the general equation. A multiplied brackets is opening x squared plus b divided by a multiplied by x brackets is closing plus c is equal to 0. If we look at the expression in parentheses, we can see that we are a little closer to the quadratic trinomial. We need the number 2 before the second term, and also we need the third term of quadratic polynomial. Multiply and divide by 2 the second term. Then we get a multiplied brackets is opening x squared plus 2b divided by 2a multiplied by x brackets is closing plus c is equal to 0. Remain the free term unchanged. We have multiplied and divided by 2. If we simplify by 2, we will get the previous expression. Now we have to add a third term to get a full square trinomial. What should be the third term? It must be equal to the square of the coefficient of x. Here it is b divided by 2a. Consequently, the third term is b squared divided by 4a squared. Since we have added the term to our expression, we have to also subtract in order to keep the equivalence of the equation. Minus b squared over 4a squared. Remain the free term unchanged. Finally, we got the necessary quadratic trinomial. Take out minus b squared over 4a squared from the brackets. Then we get a multiplied by bracket is opening x squared plus 2 multiplied by b over 2a multiplied by x plus b squared divided by 4a squared brackets is closing minus b squared divided by 4a plus c is equal to 0. Finally, we have the full allocation of the square, where x squared is the first term, 2b divided by 2a multiplied by x is the second term, b squared divided by 4a squared is the third term of the quadratic trinomial. Now, we write the expression in the form of a perfect square using the formula. A multiplied by brackets is opening x plus b divided by 2a brackets is closing in a square minus b squared divided by 4a plus c is equal to 0. Three terms will be moved to the right. A multiplied by brackets is opening x plus b divided by 2a brackets is closing in a square is equal to b squared divided by 4a minus c. Find the common denominator of the right part. The left part remain unchanged. A multiplied by brackets is opening x plus b divided by 2a brackets is closing in a square is equal to b squared minus 4ac divided by 4a. Now we move coefficient a to the right side. Brackets is opening, x plus b divided by 2a, brackets is closing, in a square, is equal to b squared minus 4ac divided by 4a squared. Let's solve the equation by extracting the square root of right and left parts of the equation. X plus b divided by 2a is equal to plus minus the square root of b squared minus 4ac divided by 2a. And if we move the term b divided by 2a to the right, then we get x is equal to minus b divided by 2a plus minus the square root of b squared minus 4ac divided by 2a. By finding to the common denominator, we get the final solution of the general quadratic equation. X is equal to minus b plus minus the square root of b squared minus 4ac divided by 2a. In this way, the general form of quadratic equation can have two roots. x1 is equal to minus b plus the square root of b squared minus 4ac divided by 2a. And the second root, x2, is equal to minus b minus the square root of b squared minus 4ac divided by 2a. The quantity of roots of the quadratic equation depends on the solution of the square roots of b squared minus 4ac. This is called as the discriminant of the quadratic equation and is denoted by the letter d. Discriminant is equal to b squared minus 4ac. So, we can rewrite the roots of quadratic equation to the following way. x1 is equal to minus b plus the square root of discriminant divided by 2a, and the second root is equal to minus b minus the square root of discriminant divided by 2a. Now we get the roots of the quadratic equation. As we see, firstly we have to find the discriminant by using the formula b squared minus 4ac, and then we have to put the solution of discriminant to the formula for finding the roots of equation. There are only three cases. The first, when discriminant is less than 0. In this case, our equation doesn't have any root, because impossible to extract the square root of negative number. The second, when discriminant is equal to 0. In this case, the equation has only one root, x is equal to minus b over 2a. And finally, the last case is when discriminant bigger than 0. In this case, the equation has two roots. x1 is equal to minus b plus the square root of discriminant divided by 2a. And the second root, x2, is equal to minus b minus the square root of discriminant divided by 2a. We found the general solution of quadratic equations. Now, let's solve our examples by using our method of finding the discriminant of quadratic equation. The first equation is 2x squared minus 7x plus 3 is equal to 0. As we remember, the formula of quadratic equation is ax squared plus bx plus c is equal to 0. Here we can see that a is equal to 2, b is equal to minus 7, and c is equal to 3. We put the values of coefficients to the formula of discriminant. Discriminant is equal to b squared minus 4ac, or discriminant is equal to minus 7 squared minus 4 multiplied by 2 multiplied by 3 is equal to 25. Since discriminant is bigger than 0, then a quadratic equation has two roots. Now we find the roots of the equation. x1 is equal to 7 plus the square root of 25 divided by 4, which is equal to 3. And x2 is equal to 7 minus the square root of 25 divided by 4, which is equal to 1 over 2. Our answer is x1 is equal to 3 and x2 is equal to 1 over 2. Let's consider the next example. X squared plus 6x plus 9 is equal to 0. As we write the values of our coefficients, we can find the discriminant of the equation. Discriminant is equal to 6 squared minus 4 multiplied by 1 multiplied by 9, which is equal to 0. When the discriminant equals to 0, the quadratic equation has only one root. X is equal to minus 6 divided by 2, which is equal to minus 3. The answer is x is equal to minus 3. Let's solve the last equation. 3x squared minus 2x plus 2 is equal to 0. We define our rates. A is equal to 3, B is equal to minus 2, and C is equal to 2, and substitute into the formula of the discriminant. Discriminant is equal to minus 2 in a square minus 4 multiplied by 3 multiplied by 2, which is equal to minus 20. We have calculated that the discriminant is less than 0. As we can't find the square root of a negative number, in this case a quadratic equation has no roots.